A number is selected at random from the set below. What is the probability that the number is even? -3, -2, -1, 0, 1, 2, 3. To find the probability that the number is even, step number 1, I have to count how many even numbers. -2, 0, and 2. These are the even numbers. So we have 3 even numbers. And we have to count how many numbers do we have. We have 7 numbers. This is our final answer. So the summary. To find the probability that the number is even, what you need to do is to count how many numbers are even divided by the total number.
The question says, a number is selected at random from the set below. What is the probability that the number is odd? Now the numbers we have are -3, -2, -1, 0, 1, 2, and -3. Since the question asks, what is the probability of the number being odd? So, let's exclude all the even numbers. In our case, the even numbers are -2, 0, and 2. We are now left with -3, -1, 1, and -3, which are all odd numbers. So in total, we have 3 even numbers and 4 odd numbers, which equals to 7 numbers in total. And since we have 4 odd numbers, the probability of us choosing a random number and it being odd is 4/7.
The faces of a cube are numbered from 1 to 6. What is the probability of not rolling a 5 on a single toss of this cube? So the probability not rolling a 5. When a single die is thrown, there are 6 possible outcomes. We have 1, 2, 3, 4, 5, and 6. Number of ways it can happen 5. So total number of outcomes is 6. Total is 6. So we need a number less than 5. 1 is less than 5, 2 is not 5, 3 is not 5, 4 is not 5, 6 even it's not 5. So the chosen numbers are 1, 2, 3, 4, 5. So 5/6 is the final answer. Thank you for watching.
The accompanying Venn diagram shows the results of a survey asking 100 people if they get news by reading newspaper or by watching television. What is the probability that the person selected at random from this survey does not claim television as a source of getting the news? So, 65 people claim television as the source of getting the news, and 55 people claim newspaper as the source of getting the news. So, the formula of probability of an event happening is equal to number of ways it can happen over the total number of outcomes. The probability that a person selected at random from this survey does not claim television as a source of getting the news. Close the bracket, which is equal to 15, which is outside the television circle, plus 20 over 100, which is the total number of outcomes. 15 plus 20 is 35 over 100. So the answer is 2.
What is the probability of tossing 4 coins and getting exactly 2 heads? At first, we have to find the probability of exactly 2 heads. Let's find out how many of the total possibilities have 2 heads of the total of equally likely possibilities. The probability of exactly 2 heads. So we know there are 16 equally likely possibilities. How many of those have 2 heads? To save time, I've drawn all of the 16 equally likely possibilities and how many of these involve 2 heads. Let's find out how many of those involved 2 heads. This one over here has 2 heads. This one over here has also 2 heads. This one over here has 2 heads. This one over here has 2 heads. This one over here has 2 heads. And this one over here has 2 heads. So if we count them, we have 1, 2, 3, 4, 5, and 6 of the possibilities have exactly 2 heads. So 6 of the 16 equally likely possibilities have 2 heads. The probability of getting exactly 2 heads equals 6 over 16. So we have a 3 over 8 chance of getting exactly 2 heads.
What is the probability of tossing 4 coins and getting exactly 2 heads? Now, to make everything easier for you, write down all the possible probabilities. Now try to find all the possibilities that have exactly 2 heads. After you're done finding them, you just have to see how many have. And in our case, our table ended up having 6 2 heads. Now, the total probabilities we have are equal to 16. So that's the total outcomes. And then for the last step, you have to divide the number of favorable outcomes, which is 6, over the number of total outcomes, which is 16. For our case, this will leave you with 6 over 16. And then, since you can simplify that number, you go ahead and do so. So the final answer will be 3 over 8.
Sarah and Lana are playing a game where they roll a pair of fair six-sided dice and try to predict the outcomes. Sarah thinks that the probability of rolling a 1 and a 3 is greater than the probability of rolling a 1 or a 3. Lana disagrees. She thinks that the probability of rolling a 1 or a 3 is greater. So let's find out who's correct. Lana's probability will be rolling a 1 or a 3. Let's write down Sarah's probability first. Sarah's probability will be rolling a 1 and a 3. So we have to count how many times 1 and 3 has been rolled together from the shown outcomes. 1, 2. They've been rolled together 2 times. So 2 over the total number of rolled dice, which equals to 36. Now let's write down Lana's probability. Lana's probability is rolling a 1 or a 3, which equals to, we have to count how many times a 1 and 3 has been rolled, together or not together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 times. So 20 over 36. As we can see here, the probability of rolling a 1 or a 3 is greater than the probability of rolling a 1 and a 3. So Lana is correct. Thank you.
What is the probability of rolling a 6 at least once in 2 rolls of a standard 6-sided dice? Each roll has 6 possible outcomes, so the possible outcomes in 2 rolls is 6 by 6, which is 36. The rule of probability is probability of an event happening equals to number of ways it can happen over total number of outcomes. Let's count the number of outcomes with at least a 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The probability of rolling a 6 at least is 11 over 36. A recent survey of 150 owners of cars in Dubai revealed the following data. First, we're going to fill in this data. Now, the total number of BMW is 45. So, you're going to think of a number that you add with 20 gives you 45, which is 25. Next, the total number is 150, so we're going to write it here. And now, you will think of a number that you add these two with and gives you 150, which is 80. And you will think of a number you add with 40, which gives you 80, which is 40. And the same here, you're going to think of a number that you add with 80, which gives you 150, 70. Now that we filled in the table, we're going to solve. From these results, the probability that a person chosen at a random from Dubai would own a Mercedes is 4 over 15, 1 over 2, 8 over 15, or 3 over 10. We have a rule of probability, which is probability of an event happening is equals to number of ways it can happen over total number of outcomes. Now, the probability that a person chosen
at random from the buy would own a Mercedes is equal to, now the total number of outcomes we have here is 150. So you will write 150 here, and the total number of Mercedes is, so you're going to write 80 here. Now why did we write the total number of Mercedes here? Because they're asking about the Mercedes. Now we're going to divide this, which is equal to 8 over 50. The answer will be C. Thank you.
In a survey, 607 general surgeons and orthopedic surgeons indicated major professional activity. The results are summarized in the table above. If one of the surgeons is selected at random, which of the following is closest to the probability that the selected surgeon is an orthopedic surgeon whose indicated professional activity is research? A. 0.122, B. 0.196, C. 0.318, D. 0.379. So here the denominator is going to be 607. Okay. But the question is, which of the following is closest to the probability that the selected surgeon is an orthopedic surgeon whose indicated professional activity is research? They need the probability that we selected or choose somebody who is an orthopedic surgeon who is interested in research. So orthopedic surgeons interested in research are these 74 people. In a calculator, we're going to divide 74 by 607. The answer will be 0.122. Then the probability of the selected surgeon whose indicated professional activity is research. So as I mentioned before, the answer is 0.122. So it's A.
The question says, the tree diagram shows the composition of a box of used color markers in a classroom. There are 2 red markers, 4 green markers, and 6 blue markers. Let's write them down. So 2 red markers, 4 green markers, and 6 blue markers. 1/2 of the red markers have dried out. So half of the 2 red markers are dried. So one of the red markers are dried and the other one of the red marker is not dried. 25% of the green markers are dry. So 25% of the 4 green markers are dry, which is only 1 dried green marker, and the other 3 green markers are not dried. And 50% of the blue markers are dry. Half of the 6 blue markers are dried. So 3 of the blue markers are dried, and the other 3 of the blue markers are not dried. What is the approximate probability that a marker randomly selected from the box will be dried out? A. 0.063, B. 0.417, C. 0.333, D. 0.538. So they're asking us the probability of a marker randomly selected from the box will be dried out. So let's write it here. A marker randomly selected from the box will be dried out. So now, in order to find the probability, we're going to do as a fraction. The bottom of the fraction will be the total number of the markers. So there are 2 red markers, 4 green markers, and 6 blue markers. In total, there are 12 markers. And they are asking us for the markers that are dried out. So there are one dried red marker, 1 dried green marker, and 3 dried blue markers. In total, there are 5 markers that are dried out. So this is the answer as a fraction. However, we want it as a decimal. So as a decimal, it will be 0.417. So the answer is B. The answer is B. Hope you understand. Thank you.
Suppose that for a certain city in the UAE in any given year, the probability of a sandstorm is 0.15 and the probability of rain is 0.08 and the probability of both a sandstorm and rain is 0.02. What is the probability of rain given that a sandstorm hits? So we have here the sandstorm is 0.15, so I'm going to call it A. And then the rain, the probability of the rain is 0.08, so I'm going to call it B. And then the probability of both is A and B. So to find the probability, I need to use the conditional probability formula. So the formula says probability B given A equals probability A and B over probability of A. So we just need to replace the numbers here in the formula. So as we solved here, so we can see that 0.15 is A and 0.08 is B, and A and B is 0.02. So here we need the probability of A and B. So the probability of A and B is 0.02. So 0.02, and the probability of A is 0.15. So let's check which answer is it. So it's going to be this one.
The probability that Ahmed smokes is 3 over 10. The probability that he smokes and develops lung cancer is 4 over 15. Find the probability that Ahmed develops lung cancer given that he smokes. Now the conditional probability formula states that the probability of A given B equals probability of A and B over probability of B. So here they tell you the probability of Ahmed smoking, and that it's 3 over 10. That's your first piece of given information. Next, they give you the probability of him smoking and developing lung cancer, which is 4 over 15. And using this information, you can now go ahead and substitute your numbers into the formula. So here, 4 over 15 is the probability of A and B, and then 3 over 10 is the probability of B. All you need to do is divide 4 over 15 by 3 over 10. Using a calculator, divide 4 over 15 by 3 over 10. Your final answer will be 8 over 9.
Inclusive events. This means that they are not mutually exclusive, so they can happen at the same time. Suppose that of 1,400 students, 550 takes mathematics, 700 takes physics, and 400 takes both mathematics and physics. What is the probability that a student selected at random takes mathematics or physics? 550 takes mathematics, so we're going to write here 550 over 1400 takes mathematics, plus probability that they take physics, which is 700 over 1400. So now I need to go ahead and subtract where both happens. So how many takes mathematics and physics? Well, 400 takes both. Subtract 400 over the total, which is 1400. Takes both. So minus 400 over the total 1400. So we go ahead and add them together. So 550 plus 700 minus 400, which will give us 850 over 1400. If I reduce this fraction, I would get 17 over 28. And if I divide it out, I get 0.0607. So this is the final answer for this question.
The table above shows the ages and genders of students in a drama club. If one student is selected randomly from the club members, what is the probability that the student will be a girl or be 11 years old? So our probability will be that the student randomly selected will be a girl or be 11 years old. These two events are not mutually exclusive, so we'll have to apply the probability of a union formula, which is the probability of the student randomly selected being a girl plus the probability of the student randomly selected being 11 years old minus the probability of the student randomly selected being a girl and being 11 years old. So the probability of the student being a girl is 18 over 33, the total number of students, plus the probability of the student being 11 years old, which will be the total number of students that are 11 years old is 9. So it's 9 over 33, the total number of students, minus the probability of the student randomly selected being a girl and being 11 years old, which will be the total number of students is 33. So 23 and 4. After adding them together, we will get 23 over 33. After converting it to a decimal, it will be, and rounding it to the nearest 1000, the answer will be 0.697. So the answer is C.
There are 2,400 subscribers to an internet service provider. Of these, 1,200 on brand A computer, 500 on brand B, and 100 on both brand A and B. What is the probability that a subscriber selected at random owns either brand A or brand B? What I need to do is I need to figure out, well, what's the probability of owning a brand A? The probability of owning brand A plus the probability of owning brand B, subtract the probability of those who ain't on brand A or brand B. A and B. There is 1,200 over the total, which is 2,400, plus 500 over 2,400, subtract 100 over 2400. So I add 1200 plus 500 minus 100, which is equals to 1600 over 2400. If I reduce this fraction, I would get 16 over 24. And if I divide it, I would get 0.6 repeated. So this is the answer of this question.
The table above shows the genders of students who visited a youth club over 5 days. If one student is selected randomly from the club members, what is the probability that the students will be a boy or be on Wednesday? Option A, 0.868. Option B, 0.763. Option C, 0.632. And option D, 0.237. Let's find out the correct option. At first, find the probability of a boy or Wednesday. Probability of boy or Wednesday. These two events are not mutually exclusive, so we'll have to use the probability of a union formula to solve this question, which is the probability of a boy or Wednesday equals probability of a boy plus the probability of Wednesday minus the probability of a boy and Wednesday. The probability of the boys is the total of 24 over the total number of students in the youth club plus the probability of Wednesday is the total students who attended on Wednesday. 9 students attended over the total of 38 students minus the probability of boys and Wednesday is the total of boys who attended on Wednesday. 4 boys attended over the total of 38 students. 4 over 38 students equals 29 over 38. To convert it to decimal, the correct answer is 0.763. Since we converted 29 over 38, the correct option is B, 0.763.
Sasha has a ring plate that has 3 gold rings and 5 silver rings on it. With her eyes closed, she picks a ring from the plate and then puts it back. She mixes the rings and then chooses another one at random from the plate. Calculate the probability that Sasha picks A, 2 gold rings, B, a gold ring in her second row.
So the first thing is, construct your tree diagram. We have 3 gold rings on the plate, and then we have 5 silver rings on the plate. The total of all rings on the plate are 8. Now for our second pick, we have the same probabilities. So we have a gold ring, which is the probability of that is 3 over 8. And then we have the probability of choosing a silver ring, which is 5 over 8. And then the same thing for the silver ring. The probability for choosing a silver ring is 5 over 8. And then the probability for choosing a gold ring is 3 over 8. Now let's start writing all the possible outcomes. Our first outcome will be G and G. Our second outcome will be G and S. Our third outcome will be
S and G, and then our last outcome will be S and S. Now for all the probabilities. Starting off with the first one, it's 3/8 multiplied by 3/8 equals to 9/64. Second one, 3/8 multiplied by 5/8 equals to 15/64. Third one is 5/8 multiplied by 3/8 equals to, again, 15/64. Lastly, 5/8 multiplied by 5/8 equals to 25/64. You can also check to see that all the probabilities in the last column add up to 1, meaning that 9 plus 15 plus 15 plus 25 equals 64. So that will leave you with 64/64, which equals to 1. Now let's say we want to find the probability of getting 2 golds. First, locate the G branch, then follow the second G branch. As you'll be able to see, there will be 2 outcomes where the second ring will be gold, either GG or SG. And so from the probability tree diagram, we can see that GG is equal to 9/64, and then SG is equal to 15/64. Now add these two together. Your answer will be 24/64. Simplify if you can. In our case, we can. So our final answer is 3/8.
Maryam went to play soccer and loves being the goalkeeper, but that depends on who is the coach today. With Coach Ahmed, the probability of being a goalkeeper is 0.5. With Coach Abdullah, the probability of being a goalkeeper is 0.3. Ahmed is a coach more often, about 6 out of every 10 games, a probability of 0.6. So what is the probability that Maryam will be a goalkeeper today? Let's build the tree diagram. First, we show the 2 possible coaches, Ahmed and Abdullah. We will start by drawing them like this. The probability of getting Ahmed is 0.6, so the probability of Abdullah must be 0.4. Now if Maryam gets Ahmed, there is 0.5 probability of being a goalie and 0.5 of not being a goalie. We will write it like this. Now let's calculate the overall probabilities. This is done by multiplying each probability along the branches of the tree. Here's how to do it for Ahmed Yes branch. When we take the 0.6 chance of Ahmed being the coach and include 0.5 chance that Ahmed will let Maryam be a goalkeeper, we will end up with a 0.3 chance. But we are not done yet. We haven't included Abdullah as a coach. If she got Abdullah, there is 0.3 probability of being a goalie and 0.7 not. A 0.4 chance of Abdullah as a coach followed by 0.3 chance gives 0.12. Now we add the column. 0.3 plus 0.12 equals 0.42. Probability of being a goalkeeper. That's 42 percent chance. The final step is to complete the calculation and make sure they are equal to 1. 0.3 plus 0.3 plus 0.12 plus 0.28 equals to 1. So it's correct.
The circumference of a circle is 36 pi. Contained in that circle is a smaller circle with area 16 pi. A point is selected at random from inside the larger circle. What is the probability that the point lies in the smaller circle? So, we have a circle. The circumference of that circle is 36 pi. Then lies a smaller circle, and the area of that smaller circle is 16 pi. We need to find the probability that the point also lies in the smaller circle. So first we need to find the area of the larger circle. So C equals 2 pi r, which is 36 pi equals 2 pi r. Divide by 2 pi, divide by 2 pi, cancel, and the radius is 18. Then we're going to find the area. So A equals pi times radius to the power of 2, which is pi times 18 to the power of 2, 18 times 18. The area of the entire larger circle is 324 pi. So we found the area of the larger circle. Okay, so the probability is 16 pi over 324 pi. Cancel, cancel. It's 4 over 81.
Giving a test to a group of students, that grades and genders are summarized below. If one student was chosen at random, find the probability that a student got an A. So we want to find the probability that a random student received an A. Looking at the table, notice how this column on here tells us the number of an A students. There were a total of 30 A students, 13 of which were a male, and 17 which were a female. Now looking at the total column in here, we noticed that the total column in 31 males took the test and 37 females took the test. Therefore, there were a total of 68 test takers. And therefore, the probability that a student chosen at random would have gotten an A would be the number of the students receiving an A, which is 30, divided by the number of students that took the test, which is 68. So equals 30 divided by 68. We do want to make sure that the fraction is in simple form. Notice that 30 and 68 do share a common factor of 2. So we're going to divide by 2 and here divided by 2. So P equals 30 divided by 2 and 68 divided by 2. And the answer is here, 1534. This is a fraction is in simple form. Let's also give the probability as a decimal. And even though it doesn't ask as a percentage, so to convert the fraction to a decimal, we will divide. So 15 divided by 34 let's round this to 4 decimal places. Approximately 0.4412. So the decimals values of is going to be an approximation 0.4412. So let's also write this as a percentage. To convert a decimal to a percentage or multiplying by 100. So this would be a P by 2, 68 divided by 2, and 15 over 34, approximately 0.4412 equals 44.12 percentage.